Before moving on to integration, let me just quickly show you the very basics of differential equations. So suppose suppose you're given something like this: y equals blah blah blah. If you differentiate this, it will give you dy by dx equals this thing here. But then suppose you start from here. Suppose you were given this. So suppose you start you start from here. You were given this, and then if you're given this here, then you can actually integrate it and say y equals this thing here. So the idea behind differential equations is that you get given dy by dx equals, let's say anything, f of x over here. Okay, so when given this thing here, you can actually integrate it and say y equals equals this thing here. You can actually integrate it, and well, when given this here, you can actually say y equals blah blah. So the idea behind differential equations is that when given dy by dx equals, let's say f of x here, what you do, what's actually happening is that you times both sides by dx. So on this side, you will get dy, and then on this side here, you will get f of x. Remember, you're timesing both sides by dx from here. You're timesing both sides by dx. That will then take you to here, and then you integrate this. You integrate both sides equally. Well, this thing here, you can imagine as being a 1 dx, but we don't normally put the 1 there. But you can imagine the 1 as this. Now integrate this side with respect to y. That will then give you y. And then on this side here, on this side you would really integrate this side with respect to x, and then that will give you whatever here, and then you have your solution: y equals blah blah. Let me just give you a quick example. So just remember, when given this here, what you do is you times both sides by dx. That will then give you dy blah blah blah. Let me give you an example. So you're given dy by dx equals this thing here. The aim here is to find the solution, which will be y equals something. This is what we want. Okay. So when given this here, times both sides by dx, and then divide. But basically, get all the x's and all the y's. Get everything related to y over on this side. Get everything related to x over to this side here. So when given this here, times both sides by dx, that will then give you this minus xy and then dx over here, and then get the y over to the other side by dividing both sides by y. So you have dy over y, and then minus blah 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 here. That will then give you this. Okay, so group all the y's and then all the x's on the right hand side. Get all the y's on the left hand side. That will then give you this. Now integrate equally to both sides. So we can imagine this as being 1 over y dy if we want to. Okay, because it gets multiplied to the top anyway. So once you're here, integrate equally to both sides. That will then give you this. And by the way, when you integrate this, when you integrate, you can imagine this as being a negative constant, and then that you can actually take the constant on the outside and just concentrate on integrating this bit here. Okay, there is a law that says you can do this. Well, when there's a minus here, you can actually take it out of the integral here. Okay, and then just concentrate on finding the integral of this, and then whatever the answer is in here, then stick a minus. Well, there is a law that says you can do that. Well, anyway, from here, that will then take you to here. Okay, and now integrate this with respect to y. So what would differentiate to give us 1 over y? Well, log of what? Well, if you integrate this here, it will give you this plus a constant. Okay, integrate this, it will give you integrate this here, it would give you this here. Okay, and then well, there's a minus there, so it becomes this. By right, there should be a minus this constant, but we don't really care. It's just a constant. It's just a number that we don't care about. So we can just say it's this. Okay, and then here you've got a constant that you don't care about. Here you've got a constant that you don't care about. If you want to minus C1 from both sides, that will then give you this. But then you don't care about these two, so let's merge these two together to give you C. The point is that you've got a constant here, you've got a constant here. These are constants that you don't really care about. You can just merge them together to give you one, to give you a constant that you don't really care about. Okay, let's just call it C here. Okay, so from here, that will then take you to here. And now exponentiate both sides. So E equally to both sides. So from here, E this side, and then E this whole thing here. So imagine this whole thing here as being a bubble here. So you E this side, and then you E this side as well here. So that will then so this is your bubble here. Okay. So that will then take you to this, and remember these are inverses of each other, so it just becomes Y. So this thing here becomes Y, and then here you've got E to the power of this whole thing here. Okay, and then remember that well whenever you have x to the power of a plus b, that equals this thing here. Well so here you've got one thing timesing this thing here, so it's us using this property here. But then don't forget, C is a constant. C is a number that you don't care about, and then you're going to have e to the power of a number that you don't care about. Let's just call the whole thing here a constant, a new constant here. Okay, it's just a number that you don't care about, and then you're gonna e to the power you don't care about. You're gonna get a number that you don't really care about. So let's just call it a. Okay, and then that will then take you to here. Tidy it up, and then that. So here y equals this thing here. So this is your solution here. So when given dy by dx equals this thing here, the general solution here would be this. And then if you get a graph plotter and plot this, in this case here, a actually is 4. In this case here, if you change a to a 3, you'll probably get something like this. If you change a to a 2 here, you will probably get something like this. The point here is that a is a constant; it changes. So looking at this here, what it's saying here is that dy by dx equals this thing here. So what it's saying is that suppose let's say this point here is 2, comma 0.5. Okay. So if you look at this point here, the gradient here will be negative 2 times 0.5. That's one way of interpreting what's going on here. If you look at this point here, if you put this into here, okay, and then here is 0.5. If you put 0.5 into the y here, then the gradient at this point here is equal to this times this with a minus stuck in front of it. Okay, that's one way of interpreting it. But the point is that when given dy by dx equals this thing here, the general solution here would be this. Okay.